Welcome, everybody. This is Esri and MarkLogic. My name is Anthony Roach, a product manager for MarkLogic. Since joining MarkLogic a couple years ago, I actually was the product manager for MarkLogic's geospatial features. So that put me in touch with these fine folks from Esri and continued the partnership that actually has been going on for a number of years before I joined. In addition to geospatial, I've actually been working on a lot of our analytics capabilities, which puts me in a perfect spot to kick this talk off. Location analytics is something that Esri has been doing for a long time, and they recognize the power of using location or geospatial data along with analytics to find new insights and help people run their business. MarkLogic, we have, as a multi-model database, we have been ingesting and managing geospatial data for a number of years as well. Our customers understand the power of geospatial data, and they've been using it along with Esri and other tools to find new insights by integrating that data and finding those capabilities. I'm going to talk a little bit about some of the typical use cases we see, how MarkLogic and geospatial data are working together. So in the assurance industry, data integration is something that they've been using for a long time to understand risk and file real-time analysis of their data. Insurance is a location-driven business. Geospatial tools from Esri have been used to understand the location and understand the risk around the data. In the healthcare industry, Customer 360 and real-world evidence are a couple of use cases that you may have heard about on this conference. This is where data is integrated so healthcare companies can understand more about their customers and patients and understand the data better. Whether looking at patient populations or regional trends or being able to make decisions about where to deploy their assets, the geospatial components of the data have become very important to these industries, and they're using GIS tools along with tools like MarkLogic to integrate the data and understand both components. Of course, government and public sector have been using GIS tools for a long time in intelligence and national defense aspects. Use cases like situational awareness are very geospatially based, and tools like Esri have been very commonly used in those. As people are starting to integrate more and more data, we are seeing that tools like MarkLogic that can integrate data faster and easier are being used to integrate more data and provide better insights to those government organizations. I'm going to pass this on to Ben Conklin from Esri, who is going to talk a little bit about what they call their patterns of use and see how geospatial data is being used to integrate data. Thanks.
Yeah, thanks a lot. So who here loves maps? Anybody? I love maps. Oh man, this is awesome. You guys are in the right room. This is really cool. Yeah, so I love maps. And why do I love maps? Because they're a great way to communicate and share information. People can use a map to understand what's happening around them. It puts information in context, in time and space. And people understand maps. They know how to read maps. They know how to use maps. And so it's a great way to portray lots of data and lots of information all at once and for people to get it and understand it. So I love maps. And one of the things, though, that I do want to talk about is that really when we think of GIS, that's always what we think of first. And it's definitely an important role of a GIS to put our data on the map and give it that context spatially so we can see where it is and see what's happening around it. There's a lot of other uses of GIS, though, that go beyond that. We call these kind of our patterns of use, typical ways that people use GIS to run their business or make the world safer or help respond to disasters or emergencies. And we see these things being used in many different ways. So managing data, curating content. So you can think about, people, of course, use the GIS to collect foundational data like the locations of roads and manholes and locations of hospitals and shelters where assets are. Increasingly, it's being used to enable field mobility across multiple people out in the field collecting data, sharing information. It's used for monitoring, I think as Anthony was mentioning, a situational awareness type application, seeing what's happening where, connecting it to sensor feeds and information coming in to the system. Definitely being used for analysis. So, we've about 40 years now, we've been using GIS to do analysis, landscape planning, analyzing the impact of, on the environment of various man-made activities, using it to understand potential, future sites and planning. And then what we're seeing though now, I'd say kind of that bottom part is really what's happened is in the past, I'd say GIS was really a back office tool. So it was used in the back office and it was used to do these really hard jobs, managing data, doing analysis. What we've seen though now is as we've kind of moved into this world of the web and web-based mapping, more and more people want to use maps in a daily part of their lives. They want to use it to support decision making. They actually want, the executives want the map, the authoritative map about the operations of the organization to be at their fingertips while they're planning for new things and making decisions. People use maps to involve their constituents, like governments, involve constituents in the running of the government by giving feedback about what's happening in the community. Or companies are reaching out and using mapped information to share and connect with their customers. And then really ultimately it's about sharing collaboration. Basically everybody in an organization wants access to maps. They want to be able to share their authoritative content using maps, and they want to be able to collaborate on that content. And to expand on that a little bit, I just want to talk about some of these examples of how these patterns are applied in specific type organizations. Some of the examples like Anthony was mentioning earlier. So you think about petroleum companies. So all the leading petroleum companies use ArcGIS, and actually, and most of them are also MarkLogic users as well. And what they use them for is a variety of things. Of course, they use it for mapping and visualization. They want to see where their assets are, and they want to see what's happening with them. They use it to plan and analyze. They use it to understand, new ways to optimize and have efficiency in their operations. They use it to help make decisions about where they should drill next, where they should. Are there issues anywhere along their pipelines? Is there maintenance activities that need to be done? And they use it to plan future sites. When you think about it inside of commercial spaces, it's used in a variety of different ways. One of the quintessential uses of GIS in the commercial space is site selection, figuring out where you're going to place stores. Starbucks, when they put two Starbucks across the street from each other, it wasn't an accident. They actually did it because they did GIS analysis, and they realized that people only want to turn right into that Starbucks. And so they mapped it out, and they understand where to place those stores and to maximize traffic. And Walmart uses it to place their new stores. Every time you hear a new Walmart opening up across town, they use the GIS to do that, and they use the GIS to figure out where that is and where that should be. And so that's helping drive those decisions. It's also helping them track what's going on. We have great stories of examples of Walgreens, for example, using maps and analytics to predict flu outbreaks a week ahead of the CDC because they have information about their patients and what they're coming in for, the kinds of medicines they're using, and they're able to use that as a measure to predict activities. So they're using it to support those kind of robust analytics. And what's happening is these organizations are sharing their maps with everybody in the company so they can actually use it to make decisions across the company rather than, again, being locked up in a department. Now, of course, area that's near and dear to me, I'm the Defense and Intel Industry Manager for Esri. This is what I've been focused on. It's a lot of actually what drove kind of Esri and MarkLogic to work together is working with our defense and intelligence customers. They have really complex requirements. So you think about intelligence data that's being collected. It's in a variety of different forms and formats. People are capturing stuff in textual reports. They're capturing chatter coming off social media, things like that. They use MarkLogic to integrate information like that. And then that information is fed into a system then to help be used to have situational awareness, maybe monitoring, what are the bad guys doing? What are they up to? Where's my friendly forces? What's happening in the field? They actually share information from these systems out into the field. They take it out in the field and they use it both just as a map to know where they are in the field, but also to actually collect information on top of the map and to share plans and orders and to share information with each other and then actually make decisions and understand the impact the terrain's going to have on their operations, understand the impact the enemy might have on their operations, and they use the GIS to help them make those kinds of decisions. I'd say one of the biggest growth areas from my perspective is really in the use of GIS inside of operations centers. So definitely every single major operation disaster center, response center has GIS front and center in those operation centers. The big screens on the walls have information displays that we call dashboards that tell them what's happening after an event occurs. So after an earthquake, for example, Cal OES uses GIS to see the impact of that earthquake, to understand where to mobilize resources, to look at the status and availability of shelters. They use it, though, not just in the response to a disaster, but also in preparing for that disaster, to evaluate is there measures they could take in advance to reduce the potential damage in a disaster, to be more resilient with their population. And they also use it in the recovery efforts. So after a disaster, the immediate response, of course, is what you see on the news, but every major disaster has a long tail of activity that's required to recover from that disaster. And what we see with these operation centers is these aren't just the government response. This isn't just FEMA's and the Cal OES's of the world. It's also commercial operation centers. So if you guys didn't know, Disney has one of the largest emergency response centers underneath Disneyland. They run their operations using GIS across their parks. Walmart has an amazing emergency response center. As those retail outlets are some of the biggest responders in a disaster. We're seeing the data and information around disasters and around events being shared then across insurance companies to look at things like, how much am I going to have to pay out, or maybe to combat fraud. So looking at what was the, people's roofs that were already damaged that suddenly, this is hurricane damage. Finding that and preventing that kind of fraud. So saving significant amount of money preventing fraud. Being able to plan, maybe look at their assets overall. Are they insuring people in disaster areas, maybe too many, maybe more than they're comfortable with from a risk perspective? So it's used in many different ways connected to kind of what's happening in the real world and who's being impacted. And that's very common application. And again, what you can kind of see out of those is out of all of those patterns, what's really common is they're data-driven. So GIS is really about being data-driven, making decisions based on data. And this is exactly why we work really closely with MarkLogic, because what we're trying to do is help customers make more of their data available to help them drive their decisions. So in our world, we were very traditional about structured data and relational databases. That's classic GIS data when you're capturing a road center line or a building footprint, it's relational. But what's happening is there's all these business systems that have the rest of the information about that parcel or about that building or about that house. And what we want to do is connect that business information in with that infrastructure data, and bringing those two things together can really drive new decisions. It can help you get insights out of the data that go beyond just seeing where something is, but actually understanding the true impact or the true value of your assets and understanding the response. So what we're going to actually do now is James is going to come up and he's actually going to take you through in detail how we're doing that integration and show you how that integration is being surfaced in some of our newest applications for analytics and through all the hard work he's been doing. So James, here you go.
Thanks, Ben. Yeah, so good afternoon. My name is James, and I'm a technical director with MarkLogic Consulting, and I've been working with MarkLogic customers for over 10 years now, building all kinds of different systems. And one of the common things, as Ben was saying, across all these different patterns of use really is that really most, or if not all of those organizations or those use cases require being able to take data from different sources and break down the data silos within those organizations to leverage the information to get the most out of it. And so we've been working really hard in the field over the last year to make it easier to use MarkLogic's technology together with Esri's to give you the most value for data integration plus location analytics. So the challenge I was posed with is really to look at how can we expose the spatial and non-spatial data stored in MarkLogic to all the Esri tools. It's pretty much it's just a one-liner. It's easy, right? So we also want to minimize the coding required because we've done this over the years for various customers, but oftentimes it's a one-off case, and each time we sort of have to start from scratch. So we wanted to try and make it easier to do that, minimize the amount of coding that you have to do. So we want to, excuse me, in that we want to leverage MarkLogic's multi-model capabilities, the ability to store data as documents, but also expose semantic data and leverage the ability to store geospatial and all the different types of formats that we can handle. So I'm going to drill down into sort of what the data architecture looks like behind what we've been working on. So in MarkLogic, we have what we call our sort of Ask Anything universal index, and within that index are documents. They're typically JSON or XML documents. And within those documents, for geospatial applications, there's typically some sort of geometry embedded within those documents. Those geometries are indexed and stored in MarkLogic's geospatial index. And we're leveraging a new capability that was added in MarkLogic 9 called the row index, and I'm going to talk about that in more detail, to project out a row-based view of different attributes within those documents. And so each document typically maps to one row in that view. There are cases where there might be more than one, but that's sort of the standard case where each document becomes a row in that view. So for those of you not familiar with the feature service, it's a pretty complex API. It has a lot of capabilities, but there's some fundamental building blocks to it. And those building blocks are layers. And so each feature service can have multiple layers. And each of those layers has sort of a class of features that's stored within that layer. And so each layer has multiple features within it. So our challenge here was to then map our row data via the view into the layer, and each row becomes a feature. And that data is joined together with the geometry to create a full feature with all of its fields or properties and the geometries that go along with it. So what we've ended up with is this is a picture of the sort of high-level view of the architecture that we've ended up with, and I'm going to drill down into each section. And so what we have in the middle here is really the core of the capability, and that's the Optic API. And the Optic API is fed by the template-driven extraction capabilities. And the template-driven extraction is what allows us to create the rows that feed into the Optic API that allow us to query and join together the geometry to create the features. On the outside, we're leveraging MarkLogic's REST search API by creating extensions that we expose out to a couple of components. One of them being the ArcGIS Pro Addin, and I'm going to talk in detail about that. And the other one is Coop, which is sort of a middleware component that allows us to easily expose a feature service as a HTTP service. And I'm going to talk in detail about each of these. So TDE. TDE allows us to project different views of your data. Right, this was added in MarkLogic 9, and this is a really key component to what allows us to meet the early challenges that I mentioned there. Allow you to use configuration or a declarative way of mapping the properties out of the documents into the fields in your features. So you don't have to write a bunch of code to do that. You can use a templating approach to project that data out. We can expose those views then as our layers, and the views determine what fields are available in our features. So like I said, if you're familiar with the features, each feature has a set of fields or properties that are associated with it, and the fields that are in your view determine what are in those feature. And as I said before, so each row becomes a feature that's accessible via your feature service. And ultimately, it allows us to easily create our views and expose that data out through our feature service. So this is a very key enabling part of what makes this all work, right? Another part that we've put together with this is a component called our feature service descriptors. So we needed some way to tell the connector, the code, sort of what feature services exist and what views they should be using, and then also what layers each view or each feature service has, and then setting up what I'm called the bounding query for each layer. And this is a really key part, and we're going to see a lot of this in the demonstration. It also tells us what geospatial indexes we're supposed to use when we run our queries against that layer. And it also allows us to generate these sort of metadata responses that are required for the feature service API specification. So in the first, the architecture slide, you saw a component called Coop. So Coop is it's an extensible JavaScript toolkit that's was created to allow you to easily integrate together different types of geospatial APIs, right? So you can take data from spatial API X and Y and expose that out as a feature service or as a WFS or whatever. So we're leveraging that as a component that allows us to easily sort of take care of a lot of the sort of Esri-ness of the feature service. It's an open source component. It's maintained by Esri. It runs as a Node.js Express server. And ultimately, it translates the GeoJSON data that we are producing from our backend services into the Esri JSON format that the feature service spits out. And it has this pluggable provider model that we leveraged to implement the MarkLogic sort of Coop backend. And you can get it from GitHub. So, plugging into the Coop component is the MarkLogic Coop Provider. The MarkLogic Coop Provider is a plugin for Coop, obviously. But it's a very thin shim that runs inside of Coop. It's basically a pass-through service, and all of the logic and capability all runs within MarkLogic server. Coop allows you to implement different types of feature services. You could connect it up to Craigslist and download a whole bunch of stuff, and it'll cache it in memory. But the MarkLogic implementation is pushing all of the geospatial calculations and queries and everything down to MarkLogic. Ultimately, it's responsible for translating the feature service requests within Coop into our backend Optic API calls. And it's all configured via our service descriptors that I mentioned at the beginning. And this is an open source component as well. It's available on GitHub under the Coop GitHub organization. So if you go to Coop on GitHub, you can find the MarkLogic provider that's part of that project. So the Optic API, this is sort of where all the magic happens. Is anybody in here using the Optic API for anything? Anybody? There's a couple of hands in the back. So Optic API was a new query engine that was added in MarkLogic 9. And it's a really powerful capability that allows us to join together different types of projections of the data, whether it's the data in its document format, or a row-based projection, or a triple-based projection of the data within the server. Optic API can be used to query across all those sort of different views of your documents, of your data. So, like everything in MarkLogic, we want it to scale and run fast. It distributes work across your cluster. Allows you to do joins and aggregates across your rows. So if you have row data, you can do group bys and all the sort of aggregate kind of statistics calculations that you need to do. You can join in triple data. And you can then extract out different parts of the document. So if you think back to my original data model where we're sort of joining together the rows with the geometries, we're extracting out the geometry data from the documents, joining it together with the rows via the Optic API. So here's an example of what or a representation really of what the Optic API query pipeline looks like. So does this work? Does this work? Oh yeah, okay. So at the beginning, what feeds into the pipeline are all of our rows that we've determined we want to use from the view. So the layer descriptor says use my view, use a certain view of the documents, and use that as the starting point. I can then limit what documents I pull the rows out of by using the standard MarkLogic CTS query constructs. So using MarkLogic's powerful composable querying capabilities, we can limit what documents we want to see rows from. And you're going to see a lot of this in the demonstration that I go through. You can also specify via the feature service API, you can specify a where clause, which is basically a SQL where clause that runs against the properties of the features. Right? So we select the documents from the view, limit which documents we want based on the CTS and the geospatial boundary. We then limit the rows based on the where clause that was passed in. Then we can specify what field we want to order by. We can do offsets and limits to do pagination. And then at the very end of the pipeline, we can join in the document to pull out the geometry. And then we can use a select expression to project that or to transform that document, the row and its geometry, into a valid GeoJSON document. In addition to just pulling back features, the feature service API allows you to do aggregations, aggregate calculations. So it has a whole statistics API. So we have a separate pipeline that does the statistics calculation for the feature service API. The real difference here is that we have this group by phase in the pipeline that does all the fun statistical calculations, sums, averages, all that kind of stuff. Ultimately, we spit out a JSON that goes back to Coop, and Coop returns it back in the feature service spec, the Esri JSON that they're expecting. So the last part of this that I'm going to talk about is the ArcGIS Pro Addin. So we've been working for the last 3 or 4 months now on an add-in for ArcGIS Pro. ArcGIS Pro is Esri's essentially flagship desktop tool for doing geospatial analysis. And they have a .NET SDK for building add-ins that run within their desktop environment. So our goal here was to give the users a MarkLogic search experience, but within the ArcGIS Pro environment. So once again, this is a configuration-driven component. The add-in connects up to MarkLogic, looks at your feature service configuration, and presents the user with a certain set of search capabilities. It allows you to query and explore the data in MarkLogic directly within Pro, quickly visualize your search results as what we call overlays. It's sort of like an optimized layer within Pro. And then allows you to save your searches as new layers that you can then share out, or reuse within Pro, or share out with other tools. It also allows you, then take that, you can export data. You can basically take advantage of all the capabilities that you have in Pro against your feature service. So now I'm going to go through, and if the demo gods are nice to me, I'm going to show you some of this stuff. Let me just log into this machine here. So I'm going to show you two quick demos, and I think I'm doing pretty good on time. The Insights demo. So Insights is essentially a geospatial BI tool that Esri provides that allows you to do basically very complex visualizations and analytics against really structured sort of tabular and geospatial data together within one tool. And within this demonstration, I'm going to show you how we've taken multiple data sources. We have 2 sources of information that we've integrated together into a MarkLogic data hub. We have one source is the GDELT, which is the global database of events, language, and tone. This is a database that is constantly collecting information from open source information, right? News posts, all kinds of things like that. And then we have a second source, which is the global terrorism database. The global terrorism database keeps track of sort of terrorist events that have occurred. And what we're doing was we're joining that data together inside of a data hub. We're trying to figure out which articles are talking about which events in the terrorism database. So in sort of the intelligence world, the GDELT data is like the noisy open source feed coming in, and the GTD data is like our golden records. It's the sort of system of truth. These are the things we know are true, and we're trying to match those and marry them against the things that are happening out in the world and figure out what people are talking about. Right? So I'm going to go through that real quick. And last, I'm going to show you the ArcGIS Pro, where we're going to do a similar scenario to what we do with Insights, but we're essentially not going to have to leave Pro to do some of these things. So let me switch over here. Okay. So as I said, we have I've created this. I'm not going to show the actual integration of the data. So we've done some work where we've created this sort of fusion data hub of our two data sources, and I've created a feature service that is connected up and configured to expose that data out to the Esri tools. And that's this feature service here. So if I click on that, what I see is multiple layers I have already set up. I have 4 different layers already configured for this service. But as an analyst, I want to work with that data, and I want to identify a certain subset that I want to work with in my Esri tools. None of these layers really meet my needs. So I'm going to pop over to a search and discovery application that allows me to use MarkLogic's search capabilities to sort of slice and dice the data and identify the data set that I specifically want to work with for my analysis. So this is basically a simple search and discovery app that we put together for this demonstration. It has all the sort of common features that you see in sort of search apps that we build for a lot of our customers. We have facets, we have a results list, we have a sort of geospatial visualization with all the measles up there. And so we're going to use this tool to try and identify the subset of the article data coming out of GDELT that we want to work with, right? So I'm going to start with this, and I'm going to search for, I'm interested in data or articles that are talking about ISIS. So if I run that query, I see now it went down, my total, you probably can't read, these are really small numbers. So we started out with about 1.5 million articles that we were working with. I've narrowed my result set down to about 85,000 here. But I know that ISIS also goes by ISIL, so I put that in there. Now we've expanded that back out. We have about 155,000 results that we're working with. But I also know that within my data hub, when I ingested that data, it went through this matching process. And so I know that I only want to work with the articles that actually matched against my known sources, or my sort of, my source of known terrorism events. So I enter in this term here, matched true. So now that reduces my data set pretty significantly down to like 50,000 or so. But as an analyst, I'm actually looking at a different scenario where people are starting to associate themselves in different ways to ISIS. They don't necessarily just say I belong to ISIS, they're sort of pledging themselves to ISIS. So I want to look at articles that are talking about how that is happening. So now I only want to look at records where the word pledge is within those articles. So now I'm down to about 6,700 articles. So I say, yeah, I want to work with this data. I want to expose it out to my tools. So I'm going to publish this out as a layer in my feature service. So this little UI here allows me to enter in a name. I'm going to say ISIS matched. And I'm going to say generate layer here. So this saves my query that I've spent a bunch of time as an analyst figuring out what data I want to work with. It takes that query and saves it in my layer as the bounding query. So if you remember, I mentioned before that layers have this ability to use a bounding query. And what that does is it sort of creates a virtual view of your data that's bounded by this query. So now I have this a layer within my feature service that I can pull into my Esri tools. So the tool I'm going to show you here is Insights. I already talked about. So if I have a blank workbook open here within Insights, I'm going to add some data. So I go and I select my data source that I showed you configured in the portal, and now you'll see I have a new layer there called ISIS matched. So sorry if this is a little bit small, but I'm just going to select that ISIS matched layer because that's the only one I want to work with. I'm going to add it to my workbook, and make this a little bit bigger here. So what this is doing is pulling in the points from the feature data, and over on the left I see all of the different attributes about the features that I have exposed out. So my network hopefully is going to complete here. Actually, while that's loading, let's see, hopefully this is going to, come on, network. Well, let's try and do some other visualizations while that's loading. Let's see if I can pull up a chart, because I can plot the websites that are posting the articles. I can pop up a bubble chart about what domains are posting what information, or sorry, what articles. And I don't know why those are not showing up on the map. Let's just try to close that one real quick. See if this is going to show up here. It's not showing up. Oh, there they go. Yay. What we see on card 2 here is I've visualized basically a bubble chart, which shows me the size of the bubble is determined by the number of articles from what website is talking about these various terrorist events. So GDELT has this concept of sentiment. So all of the articles are processed through this sentiment analysis. So what I can do is I can actually take my map and I can style this by the sentiment, and I can make these symbols a little bit bigger here. Oh, those are pretty big, but anyway. So I see some. If I click on sentiment, come on. I see that basically I have negative, neutral, and positive, and I see a few blue dots here in the middle that it might be a little bit strange. I have these articles that have positive sentiment about a terrorist event, so maybe I want to inspect those a little bit closer. So I can zoom in on those, and I can select over here within this sentiment. I can select which ones, so I can look at positive. And that's going to highlight which domains are actually, publishing these articles that have been deemed positive about my events, right? So that maybe that's interesting. I can pull in the event if I want to look at more information about the event. I can pull in the event ID, pop up a table, and see information about what events have the most articles posted about them. This particular one here, this data actually covers the time when the Charlie Hebdo attack happened. That's what this particular one is. And but we can do a whole bunch of cool stuff. We also have the ability to visualize, maybe we want to see what type of attacks are used against what type of targets. We can pop up a chord diagram to visualize the relationship between attacks and their target types. And sort of endless possibilities of what we could do here. So with that, I'm going to switch over though and show you what we can do within ArcGIS Pro. So within Pro, we have we've emulated or reproduced a similar sort of experience, but our goal was to not have to leave the Esri tool to go over to some sort of specialized search and discovery app to discover the data. We want to be able to do that searching right within Pro. So if I connect up to MarkLogic here, I'm going to enter my credentials. And within here, I've connected up to a different data source. This data source it's GDALT data as well, but it's not fused together with GTD. It's just pure articles. I want to look at maybe I want to find some articles about politics. So I run a query, and that's using MarkLogic Search API directly from within Pro, and running my query and returning back our faceted results here on the left-hand side. So within this results pane, I see the facets with the counts. I see all of the locations that are mentioned within those articles projected onto an overlay. And I see my results down here at the bottom. If I click on click on one of my results, I see, I see that document visualized in the MarkLogic document viewer. And the document viewer is a custom transform. You can make that document viewer look however you want. And so you can make your documents be these simple sort of table like this is, like these ones, or you can make them look as interesting as you would like. And that's all through configuration in the connector. So with this, maybe I want to actually look at, sorry. Whoa, sorry. Maybe I only want to look at a subset of the data. All right, so I'm going to zoom into the United States here. And you'll see that this is actually rerunning the query, and my result set got a lot smaller. I don't know if you can see that, but it went from a few thousand, about 6,000, down to 700. So it limited my result set by the viewport that I have visible within Pro here. And so, you can think of this sort of as a geospatial facet, right? We have a sort of the map as our way to limit what bounds we're using to query the articles. Maybe I want to also pull in, I'm running short on time, so let me just save this guy out here. Maybe I just want to look at English articles that were written in English. We have basic sort of standard faceted navigation, all the things that you're used to using in search apps within MarkLogic. Then I can take this and I can save it out as a new layer, US politics. I can save this. And what this is going to do is going to generate a new layer in the feature service, and it's going to automatically add it to the map as a new feature layer. So if I click over here, now I have a new feature layer that's been created and configured in the map. I can look at this, pull up the attribute table, see all the information about the features that I have in that feature layer. So the cool thing about this is now that I've exposed this feature data out to the ArcGIS Pro, and now I can use all the cool capabilities built into Pro for all of its awesome geospatial analysis that you can do within that tool. But then I can also take that feature layer and use it in other tools. So if I pop back over to Insights, if I look in here, I have this, if I select this other data source, I have this US politics layer that I've created. If I add that, it pops up a map. And you see that it limits the data to just the boundary that I had selected. So this is a very powerful concept where we're able to leverage the power of MarkLogic to slice and dice the data and quickly identify the data that you want to work with and expose it out to the Esri tools to take advantage of really what they're great at. So in summary, we're exposing the full text indexing, geospatial indexing, row-based indexing, all via one interface, and that interface is the feature service interface. Once again, it's configuration-based, standard interface, available to expose data to all your Esri tools. This is a key one. We want to be able to expose out data from existing applications as well as new ones. So if you're starting greenfield, you can configure the connector to work with your new system, but you can also apply the connector on top of an existing system to expose data out through that. And you can leverage your existing index configuration, work with JSON or XML documents. And ultimately, this gives you location analytics really for all of your data. So last thing I want to do is talk about really what is the next step. So we've been working on this great capability in the field, but we're also working closely with Esri on making a tighter integration with Insights. So Esri is working to make MarkLogic really a first-class data source within Insights. And Insights is building an extensible data source architecture, and MarkLogic is really the sort of the prototype version or the first NoSQL database that they're using to connect into that architecture. And they're looking to publish that at their user conference that's coming up in July. And you'll be able to search and discover data in MarkLogic directly from Insights. Much sort of like what we just did within ArcGIS Pro. The ultimate goal would be to not have to leave Insights to leverage the search and discovery power of MarkLogic. Be able to analyze and visualize your structured data projected from your documents, analyze and visualize linked data, and that's it. I was running out of time, so sorry to go fast there at the end. And yeah, so in summary, we're really happy to be working with Esri on this and really trying to bring the best of both of these tools to our customers.